the generator output can fail due to problems with the prime mover, turbine or engine that drives the generator, issues with speed controller, or different frequencies during synchronization. When the prime mover fails, the generator stops producing power and may instead start drawing power from the other parallel sources and start motoring. The reverse power relay senses any reverse direction of power flow and disconnects the generator to avoid any possible damage. Reverse power relay construction and operation. The relay is made of a lightweight non-magnetic aluminum disc between two soft laminated iron core electromagnets, and fixed on a spindle running on low-friction bearings. The upper electromagnet is wound with a voltage coil which is then supplied from one phase and an artificial neutral of the generator output. The other magnet has a current coil supplied from a current transformer connected to the same phase as the voltage in the upper electromagnet. The voltage coil has a high inductance, designed in a way that the voltage lags the current in the coil by about 90 degrees. This lag ensures that the magnetic field generated from the current in the upper coil lags the magnetic field produced by the current in the lower electromagnet. The two magnetic fields which are out of phase produces eddy current in the aluminum disc, and this creates a torque that tries to rotate the disc. Under normal condition, when power is flowing as expected, the trip contacts of the relay are open, and the disc is against a stop. If a reverse power starts to flow, the disc rotates in the opposite direction, moves away from the stop and towards the trip contacts that activates the trip circuit. Most of the reverse power relays have adjustable settings to allow the customer do the settings according to the installed equipment. The trip point is usually adjustable to between 2 and 20% of the input current, while the time delay is adjustable from 0 to 20 seconds. A 5-second time delay is often used to avoid tripping the circuit during synchronization. In most practical applications, the reverse power settings are between 8 to 15% for diesel engines and between 2 and 6% for turbine power movers. Advantages of reverse power relay: prevents power from flowing in the reverse direction and damaging the generator. Stator prevents damage to the prime mover, prevents fire or explosions that may be caused by unburned fuel in the generator. In summary, when power flows into the generator, it starts operating like a synchronous motor and the turbines or prime mover becomes the active load. This can damage the prime mover and is therefore undesirable. It is important to detect a reverse power condition and disconnect power as quickly as possible, and even though the gas turbines and diesel engines may not get damaged immediately, there is always a risk of explosion or fire from the unburned fuel. A reverse power relay helps in monitoring the power in the generator. It detects a reverse power condition, and the relay immediately removes the connection to the parallel utility or other power source, hence protecting the generator from damage.